Hello. So in this video we are going to review all concepts you need to know about sequences. First of all, what is sequence? Sequence is an ordered set of numbers. Just take a bunch of numbers, scramble them as you want, then you order them in whatever order, and that's a sequence. Of course, if there is no pattern, it's not really interesting and useful. So we are looking at two types of sequences with very special patterns as most important ones. But there are still sequences which don't have pattern or have a pattern which we don't even know. So most important two types of sequences are arithmetic and geometric. So let's look at each one carefully. Arithmetic sequence. As you know, the numbers in arithmetic sequence progress by addition. So you're adding plus 4, plus 4, plus 4. So we're adding the same number. This number is called common difference. Common difference. In general, it's notated D. In this case, D is 4. It's called difference because that's the difference between every two consecutive terms. Between 9 and 5, between 9 and 13, and so on. Geometric sequence. Here, the progression goes by multiplication. We are multiplying by the same number, times 3, times 3, times 3, and so on. This number is called common ratio and denoted R. In this case, R is 3. In the third example, clearly it's not arithmetic or geometric. It doesn't, we had 3, 5, 7, we multiply by 2.5, by 2, by something else. It's neither. It actually has a pattern that we are going to try to find. But let's just state here, other patterns or nothing, or none, no pattern, or none. Okay? So let's talk about notations. There are two types of notations used for sequences. One more common, the one that mathematicians use and I like and I will use most of the time. We are using subscripts. A first, A second, A third. So the subscript just indicates what's the ordinal number of any term. If I just want to show any term, I'm writing A sub n, which means like general term. So let's say if you look at my notation, this is first term, A first, A second, A third, and so on. Another type of notation is function notation, which I don't like to use for sequences, but common core people like it, so we have to learn it. So it goes like this: A of 1, A of 2, A of 3, and so on. A of n. Often instead of A, we use like a more function-like letter such as F. So it may be F of 1, F of 2, F of 3, and so on. But so for this last example, we can say that F of 1 equals 2. F of 3, which means the third term, equals 10, and so on. Okay, so now, in order to understand better how these are functions, let's use the table that we often use for functions. So in the first column, we'll just write the n, the ordinal number of a sequence, first term, second, third. So this is our index. And in the second column, our values of the function, or rather sequence. Oh no, this is A sub n. And this is 1, 5, 9, 13. So let's try to understand how this function works. As we already know, it increases by 4. Plus 4, plus 4, plus 4. How can we use this pattern to write an equation of this function or the sequence? So let's say if I want to find term number 10, what would it be? I'm going to write a sub 10 equals. I start with the first term, which is 1, and I keep adding. I can keep adding plus 4, plus 4, plus 4, but I just want to know how many 4s I need to add. Is it 10? Let's see. To get to the term number 4, for instance, I need to add 3 4s. To get to term number 3, I'm just adding 2 4s. So I'm always adding one less. So I only need 9 of them, and that will be 37. So in general, nth term of this sequence will be, oh, not on this sequence, but of any arithmetic sequence will be the first term plus, then I take d, n minus 1 times, 1 less than the number I want. So this is the first important formula. Do you need to memorize it? Not really. It's really easy to kind of logically produce it when you need it. But you do need to understand how it's produced. We're going to continue with geometric sequence now. So here we multiply by 3 every time. So how do you find nth term? Let's just do it for 10th term first. I start with the first one and I keep multiplying times 3, times 3, times 3. How many times? Again, for the fourth term, I only multiply 3 times, because for the first term I don't need to multiply, I already have it. So again, I'm going to multiply not 10 but 9 times. In other words, it's 3 raised to the 9th power. And generally for geometric sequence, it will be the first term times common ratio raised to n minus 1 power. So once again, this formula is kind of intuitive. For this example, okay, we really will probably not need to find a pattern for such a sequence in this course, but just as an exercise, let's look at this. Look carefully at these numbers, 2, 5, 10, 17. Did you notice anything? Well, the way I created it, I added 1 to all perfect squares in a row. So 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, and so on. So that would be my equation, really. C sub n equals the number, ordinal number of a sequence, plus 1. Do you need to memorize? No. All these equations that we just got, the purpose of all of them is to find the nth term directly, immediately, just by substituting n. For example, if I want to find C sub 100, all I need to do is plug in 100, square it, and add 1. Such equations are called explicit. So this is called explicit definition of a sequence. Register it, because in a moment we are going to look at different type of definitions. Okay, so the other type of definition is called recursive. I'm going to write it down here. Recursive definition of a sequence. So recursive definition just allows you, starting with the first term, it just tells you what to do next to get to the next term. So in this first case, we are saying, so the first term is 1, and each consecutive term you can get from the previous term by adding 4. So let's look carefully. A first is 1. Now, I will start replacing n with consecutive numbers, 2, 3, 4. So a second. Now, if n is 2, then this is 1 less, so it's 1. So a second equals a1 plus 4. A third equals a second plus 4, and so on. Little trick here. Do not substitute n here and subtract 1. Just understand, just treat them as next term and the previous term. Okay, that language will help you do it more intuitively rather than just plugging in formal numbers. What's the recursive definition for a geometric sequence? So first term is 2, and every following term, to find it, you start with the previous term and you multiply it by 3. Or you can write it as 3b n minus 1. This one is a little trickier. Take it as a little challenge. The first is easy. C1 is 2. And then, first we add 3. Then we add 5. Then we add 7. But there is a pattern here, right? 3, 5, 7 themselves can be written as, so they increase in a linear way. So I can, I guess, so I start with the preceding term here, and I can add this little linear expression. If n is 1, I need to, so it's a kind of a slope intercept form. Okay, I don't want to spend much time on it, but I want to use this example to check if this equation is correct. I'm not really, honestly, not 100% sure that it's right, because I did it pretty quickly. So that's how you will need to check it. So C1 is 2 is correct. C2 equals. So C2 follows C1. So this is my preceding term. Plus, now n is 2. You see that? So I need to substitute that. And I see that it's not correct, because this is 2 plus 5, not right. So my equation is wrong. I'm pretty sure that it must be a minus here. I'm not explaining how I know, because you will never probably have to create equation like this, not until you take calculus. But problems on this topic often come in a multiple choice format. So you need to be able to choose the correct one, and that's the strategy you're using. So let's check my new formula with the minus. C2 equals C1, again, which is 2 plus 2 times 2, now minus 1. So this will be 2 plus 3, and it's a 5. So far, so good. I'll check one more. Usually that's enough. Now, preceding term is now 5. It's a C2, and it's a 5. Now, 2n. n is 3 now. So this is what I'm using. 2 times 3 is 6 minus 1 is 5. 5 plus 5 is 10. So yes, it is correct. To conclude, I just want to stress that you learned 2 special types of sequence, arithmetic and geometric. That you learned 2 types of notations. Oh, I lied. I never used function notations with you. I only use sequence notations. Well, but you should be familiar. You should be aware of this other type of notation, f of n. Maybe we should look at one example. And you did look at 2 types of definitions. Recursive definitions, where you are given the first term and the rule how to get from any term to the following one. Please notice, this itself is not sufficient. You really need the first one to start. An explicit definition, or also it's called equation of an nth term, which allows you to find the term number n just by substituting that n number. So let's say if you need to find the 100th term, you don't need to find 99 previous ones. You can just plug in 100. Okay, let's look at one example where you can practice function notation and recursive definition. I made up a really weird sequence. I don't even know what will come out of this. So g first is -3, g second is 1, And this is my recursive rule. How you know it's recursive? Because it expresses nth term in terms of not just the previous one, but also the preceding term. Okay, pause and try to find first few terms by yourself. Just copy and solve. Okay, welcome back. So let's try what happens. So G1, I really, even though I have it, I prefer to write them all in order, in column. It's easier to work, you will see. So G of 3. So what my rule says, take the term before and the term before that. I'm not going to substitute 3 here. It's easier to look at this like holistically. A term, term before that, term before that. Okay, so that's what I'm going to do. The previous term is 1. The term before that is negative 3. I need to add 2n. What is my n? It's 3. So I'm adding 2 times 3. What is it? Minus 3 plus 6 is positive 3. Let's do a couple more. G of 4 equals. I need to take 2 preceding terms and multiply them. So I'm taking this and this. So it's 1 times 3 plus 2 times n. What's my n now? 4. So I have 3 plus 8, 11. And one more. G of 5. I need to multiply 2 preceding terms. So it's 3 times 11 plus 2 times n, which is now 5. So 33 plus 10, 43. And so on. Not too bad, right?